Are you undertaking the construction of a high-performance building? It can be a daunting task. It requires choosing the right materials, selecting the most suitable design, and working with a team of experts. But what if there was a material that solved all these problems? Something that is strong, energy efficient, and cost effective. Something like structural insulated panels or SIPs. ThermaFoam's team of experts can help guide you through your project. ThermaFoam SIPs are advanced structural insulated panels that are engineered to provide more durable and energy-efficient residential and commercial buildings. The panels are made by sandwiching a core of rigid foam insulation between two skins of structural sheathing, usually oriented strand board or OSB. The foam core of the panel is typically composed of expanded polystyrene or EPS. Structural adhesive is used to adhere the foam cores to the OSB skins in a lamination process. Once laminated, the solid panels are cut for doors, windows, and switches in the manufacturing plant, or on site, to meet the design specifications and then shipped to the site for a quick and easy installation. With ThermaFoam SIPs, building a high-performance building is a breeze. Our panels come in different sizes and thicknesses, making your job easier. Or consult our team of experts to get a distinct high-quality design. Not only do they reduce construction time, but they also allow for design flexibility. But what really sets ThermaFoam SIPs apart is their insulation properties. They regulate temperature, which means that they keep your building warm in the winter and cool in the summer. This makes them perfect for creating a comfortable and energy-efficient building. So, if you're looking to build a sustainable, durable, and energy-efficient home or commercial building, ThermaFoam SIPs are your best choice. Contact us today to get started on your project.
Welcome to our video demonstrating the proper sealant applications for R-Control SIPs. Construction Manual. Today's video will describe the application of SIP sealant as part of overall SIP construction. SIP sealant applications following construction manual details is important to ensure long-term, durable SIP structures. In all SIP sealant applications, 2 parallel 3/8" diameter SIP sealant beads are applied. This common pattern is repeated in all SIP sealant applications. Bottom plates. 2 straight parallel 3/8" diameter SIP sealant beads are applied to the bottom plate, 1 inch in from each edge. A perpendicular 3/8" diameter SIP sealant bead is applied 1 inch in from the ends of the bottom plate for each wall segment. All factory-cut electrical chase holes must be encircled with SIP sealant. Using this SIP sealant pattern will reduce air and vapor movement at bottom plates. SIP wall installation can now begin. End plates. 2 straight, parallel, 3/8" diameter SIP sealant beads are applied to the core of the SIP, 1 inch in from each edge. Perpendicular 3/8" diameter SIP sealant beads are applied 1 inch in from the bottom of the SIP and 1 inch in from the top of the SIP. All factory-cut electrical chase holes must be encircled with SIP sealant. Using this SIP sealant pattern will reduce air and vapor movement at end plates. SIP wall spline installation can now begin. Splines. 2 straight, parallel, 3/8" diameter SIP sealant beads are applied to the core of the SIP, 1 inch in from each edge. Perpendicular 3/8" diameter SIP sealant beads are applied 1 inch in from the bottom of the SIP and 1 inch in from the top of the SIP. All factory-cut electrical chase holes must be encircled with SIP sealant. The spline is installed, and the same sealant pattern is repeated on the spline edge prior to the installation of the next SIP. Wall installation. SIP wall installation can continue following the SIP sealant pattern. The SIP sealant pattern will reduce air and vapor movement at splines. When moving to an adjacent wall, SIP sealant is installed on the bottom plate as shown earlier. Two straight, parallel 3/8" diameter SIP sealant beads are applied to the SIP 1 inch in from each edge. Perpendicular 3/8" diameter SIP sealant beads are applied 1 inch in from the ends of each wall segment. Top plates. Two straight, parallel 3/8" diameter SIP sealant beads are applied to the core of the SIP 1 inch in from each edge. Perpendicular 3/8" diameter SIP sealant beads are applied 1 inch in from the ends of each wall segment. All factory cut electrical chase holes must be encircled with SIP sealant and the top plate installed. The same pattern is continued for top plates in all wall segments. Using this SIP sealant pattern will reduce air and vapor movement at top plates. The use of SIP sealant at bottom plates, end plates, splines, and top plates results in a virtually airtight wall installation. SIP roofing. SIP roofs are sealed in the same manner as shown earlier for wall construction. SIP roofs must also be sealed where they meet the top of SIP walls and where they overlay structural beams. SIP tape. Additional sealing must be done with SIP tape. Please consult the construction manual for installation instructions. The use of SIP sealant properly applied to spline connections, boundary end plates, with the addition of SIP tape, results in a virtually airtight installation. For more information and details, please refer to the R-Control SIPs construction manual and visit our website. Thank you for watching our video. Welcome to our video demonstrating the electrical wiring of R-Control SIP walls. The anatomy of a SIP. R-Control SIPs come with vertical and horizontal electrical chases factory cut into the foam core. The typical locations for vertical chases is every 4 foot on center. Horizontal chases are located at typical switch and receptacle heights. Electrical chases may also be located to specific customer requirements when this information is provided to the SIP manufacturer prior to producing SIP layout drawings. Installing SIPs for wiring. Begin by installing the bottom plate of the SIP walls on the platform subfloor. Make sure you place the bottom plate so the outer face of the SIP is fully supported by the platform. Review the SIP layout drawing to confirm the locations of the vertical electrical chases factory cut into the cores of the SIPs. Take note of the factory cut electrical chase location markings on the face of the SIPs. On both the subfloor surface and the face of the installed bottom plate, mark the corresponding locations where the SIP vertical chases will occur. Using a drill having a boring spade or similar bit that is slightly larger than the diameter of the factory cut chase hole of the SIP, drill a vertical hole completely through the bottom plate and the subfloor sheathing. As you set the SIPs, use the location markings on the SIP face and subfloor to confirm that the bottom plate access holes and SIP vertical electrical chases are aligned. If not aligned, remark and re-drill the bottom plate access holes. Install block splines with factory cut holes in line with the horizontal electrical chases in the SIPs. When installing solid or engineered lumber splines, pre-drill holes in the solid splines and install in alignment with the horizontal factory-cut electrical chases in the SIPs. At the SIP chase locations, drill a vertical hole completely through the top plate using a drill having a boring spade or similar bit. Marking and cutting for switch, receptacle, and fixture boxes. At factory marked receptacle and switch heights, use the receptacle box as a template to mark the face of the SIP. Using a circle saw, make a cut at the intersection of vertical and horizontal chases where wiring needs to change direction. Using a rotary cutter, cut around the total marked area of the receptacle and switch openings. Preset metal templates having various electrical box sizes can be used to eliminate hand marking and speed up the cutting process. Using a hand tool, remove the cutout piece to expose the factory-cut electrical chase run. Make sure that the drilled access holes are clean and completely clear of debris. Remove any debris from the electrical chase holes in the SIPs. This will make running electrical wire easier. It's recommended that you retain cutout pieces of the receptacle and switch boxes in case you need to make location changes later. The cutout pieces can be used to plug any unused switch, receptacle, or fixture box openings. With the receptacle and switch openings now cut, wiring in the factory chases can begin. Wiring of electrical runs. Our animation illustrates the many paths by which electrical wire can now be run in the SIP walls. After wiring is completed, all switch, receptacle, and fixture boxes are installed. Air sealing for wiring. After wiring is completed, use a low expanding foam to fully seal the electrical chase behind all boxes and any unused cutouts. Remember to foam seal all interior and exterior wall electrical boxes. All wire access holes, used or unused, must also be foam filled. Electrical wiring of SIP walls can be done in numerous ways. Here are some examples of the most used platform methods. SIPs stood on a structural floor platform. SIPs bearing on a stem wall or a full-height basement wall, with the floor platform bearing on the mud sill. SIP first and second floor walls with an open platform between stories. A second story SIP wall bearing on a first floor SIP wall that's carrying floor joists and a subfloor seated into top wall joist hangers. When using this platform configuration, make sure that the second story bottom plate chase access holes and the first story wire access holes are in alignment. All these open floor and floor ceiling platforms provide excellent access for wiring of SIP walls. Electrical wiring of SIP walls constructed over slab-on-grade foundations. Wiring of SIP walls constructed over slab-on-grade foundations is accomplished from the top of the SIP wall. Electrical wiring can now be run from the top of the SIP wall or through intersecting interior partition walls into switch, receptacle, and fixture boxes cut into the SIP walls as shown earlier in this video. For more information and details, please refer to the R-Control SIPs construction manual and visit our website. Thank you for watching our video. Welcome to our video demonstrating the proper application of SIP tape when used with R-Control SIPs. Construction Manual and SIP tape. This video will demonstrate the application of SIP tape as part of overall SIP construction. We will focus first on the application of SIP tape in generally cooler northern climate zones. SIP tape is applied following the construction manual details to ensure long-term, durable SIP structures. Surface preparation and roller. All surfaces must be clean, dry, and free of dust, dirt, grease, oil, and any other contaminants that may interfere with adhesion. A soft rubber roller is required to firmly mate SIP tape onto SIP surfaces. A soft rubber roller is important to ensure the SIP tape is pressed into the textured SIP surface. Ridge beams. SIP tape is installed on the ridge beam prior to SIP roof installation. SIP tape is installed without removing the release paper and with the release paper facing away from the ridge beam. 18-inch wide SIP tape is carefully placed over the ridge beam and tacked to the ridge beam. SIP roof installation can proceed following the SIP construction manual. Details of SIP sealant are not shown here, but are available in our SIP sealant video. Once the SIP roof is in place and covered with appropriate exterior weather protection, interior SIP installation can proceed. The release paper on the previously installed SIP tape can now be removed and the SIP tape pressed upward onto the SIP roof surface. The use of a roller is required to firmly mate the SIP tape onto the SIP roof surface. Roof-to-wall application of SIP tape. 12-inch wide SIP tape is placed over roof-to-wall connections where the SIP roof and SIP walls are not flush. It's important to ensure SIP tape overlaps both the wall SIP and the roof SIP at least 2 inches. The use of a roller is required to firmly mate the SIP tape onto the SIP wall and roof surfaces. Four-inch wide SIP tape is now placed over roof-to-wall connections where the SIPs are flush. Again, the use of a roller is required to firmly mate the SIP tape onto the SIP roof and wall surface. Roof splines and SIP tape. 4-inch wide SIP tape is placed over roof spline connections. The use of a roller is required to firmly mate the SIP tape onto the SIP roof surface. SIP tape installation can proceed over all SIP roof spline joints. Wall corners and SIP tape. 4-inch wide SIP tape is carefully placed over corner connections. The use of a roller is again required to firmly mate the SIP tape onto the SIP wall surfaces. Wall splines and SIP tape. 4-inch wide SIP tape is carefully placed over wall spline connections. A roller is required to firmly mate the SIP tape onto the SIP wall surface. SIP tape installation can proceed over all SIP wall spline joints. Completed SIP tape application. The use of SIP tape applied to spline connections, wall and roof connections, and ridge beams results in a virtually airtight SIP installation. SIP tape in warm, humid climates. SIP tape installation in warm, humid climates follows the general processes shown in this video, but installation is on the exterior of the building. The construction manual provides details on the installation of SIP tape in warm, humid climates. Exterior SIP tape installation occurs at the ridge, on all roof splines, roof-to-wall intersections, wall corners, and wall splines. The application of SIP tape either interior or exterior, should be specified by the building designer based on the local climate and code considerations. SIP sealant and SIP tape. SIP tape discussed in this video is available from your R-Control SIP supplier. General use building tapes are not appropriate for use with R-Control SIPs. The use of R-Control dual-ply sealant in combination with SIP tape results in virtually airtight installation. Please watch our separate SIP sealant installation video. For more information and details, please refer to the R-Control SIP Construction Manual and visit our website. Thank you for watching our video. ThermaFoam Geofoam, the trusted lightweight fill material. The perfect solution for solving structural fill challenges. There are many challenging fill applications that need a reliable, fast, and cost-effective solution, and ThermaFoam Geofoam is the answer. Geofoam comes as large, lightweight, and easy-to-install blocks, making it the perfect material to construct high-performance structural fills. Let's take a look at some of the great applications where Geofoam proves to be the perfect structural fill solution. Lightweight roads. Transportation roadways often need to be built over unstable soils. The use of structural, lightweight Geofoam reduces construction time and the costly steps of surcharging, de-wicking, and driving piles. Geofoam delivers fast, stable, and built within budget road building. Bridge abutments. Geofoam used in the approach fill sections of bridge construction reduces lateral loads on the bridge deck support system, which reduces cost. Geofoam also prevents the potential differential settlement of the finished roadway and the bridge deck elevation. Road widening. One of the greatest challenges of widening existing roadways is the disruption it causes due to the long construction period. Using Geofoam progresses the construction process of road building faster than any other conventional methods used today. Retaining walls. Reducing lateral loads on retaining walls reduces cost of construction as well as ensuring long-term performance. Using Geofoam provides the most reliably engineered, fast construction method to build high-performance retaining walls. Plaza decks. Reducing overbearing loads on plaza decks increases deck spanning distances at lower cost. Geofoam allows for cost-effective long-span designs. And Geofoam's insulation power allows for conditioned, habitable space under the plaza deck. Foundation fill. Urban redevelopment and reclamation of historical buildings requires adjustments to floor and stair elevations to meet code egress, HVAC, and electrical standards. Geofoam elegantly and cost-effectively provides the solution for urban building retrofit. Stadium seating. The theater viewing experience enhances every great performance. Geofoam has been used to cost-effectively transform movie theaters, public outdoor venues, school auditoriums, and private viewing rooms into environments where people become immersed in the performance. Landscaping. Landscape environments having planters, rolling contours, multiple elevation changes, whether on the ground or over plaza and roof decks, can be designed more efficiently, installed faster, and at a competitive cost with the use of Geofoam. Mat foundations. Foundations over unstable or expansive soils is a challenge. Geofoam allows for soil removal and replacement with lightweight Geofoam structural fill. This provides for a net zero weight gain for the structure on the building footprint. Rail corridors. Train rail systems are being built in many metropolitan areas throughout the world. Rail corridors many times need to cross unstable soil areas. Geofoam has allowed cost-effective rail corridor construction over unstable soil areas. Slope stabilization. Mobile soils, cyclical surface and subsurface water events can affect the stability of roads and structures built on natural slopes. Designs using geofoam can provide an engineered solution that eliminates slope erosion and stabilize the native conditions. Utility protection. Overbearing fill in roadways, reoccurring live loads, and consolidating soils can cause damage to underground utility service runs. Geofoam relieves these stresses and protects critical utility runs for years to come.
As you can see from these great applications, ThermaFoam Geofoam meets the challenge of constructing many high-performance structural fills. ThermaFoam Geofoam can be installed quickly and cost-effectively, and ThermaFoam Geofoam can be trusted to perform for the life of the application. To learn more about ThermaFoam Geofoam, I invite you to visit one of our primary locations at ThermaFoam.com, PowerFoam.com, or ThermaFoam R-Control.com. Thank you for viewing our video.